In this one I will go through the basic interaction with the Tilemap. So let's create a node in question. Tilemap here. And in the simple prototyping I like to use the Godot icon. This one is, I think, 128 by 128. You can check this one here. So for the learning purposes, let's create our tile with the size of 32. So this will be 1/4 of our Godot icon. Here, let's add a new tile set, and you can either press here to go into the tile set settings, or you can do it here in the editor. Okay. Let's also change our tile size here to 30 to 32. I think this was, yes, 30 to 32. Okay, and let's now drag our icon here. Here, agree to automatical Atlas tiles creation unless you want otherwise. And here we'll left something like this. So let's create our tiles. The first one will be top left, or maybe let's make it 64 by 64. This one will be easier. So change this one here. But as you can see, you can have different sizes here and there independently. So now in our icon we have 4 different tiles. Here let's modulate this part into something like red. Modulate this one to some kind of super blue. And here maybe we'll take some green. Now if we want, we can use this one in the editor here. Like this, or we can press left mouse button and hold, or we can press a rectangle here and then we can draw a big one. And this is hold the left mouse button, and we can remove every single time with the right click, and it also works with the rectangle. Another interesting thing here in the tile set, if you remove a tile here and add it even again, then the ID will be modified to 1, but you can manually change it here if you want. What I think wasn't possible before in the Godot. I usually use tiles from the code, not from the editor. So let's attach a script here. And what are some basic functions here in our Tilemap? Let's create a simple kickstarting functions, and remember that we have a empty editor here. Let's spawn a simple tile. To do this, we use a function setCell. Here as the first argument, we need to pass a layer. What is a layer? There is something, as the name suggests, that you can use to put cells on top of each other, or you can group cells in different layers. You can, of course, create a layer from the script, but in the editor you can go here into the layers, and this is the default layer, and you can add another one here. Okay, the default layer is the 0, 1. Next we need to pass our coordinates. So for testing, let's pass a 0, 0 position. The next argument is for the tile set sources. If you don't have any specific in mind, let's just leave it as 0. And next one is the Atlas coordinates. This one is your tile identifier in the spreadsheet that you're using. How to check this one? Simply go into the Tilemap editor and hover over single tile, and here you will have all the required arguments for setting cells. As you can see, only Atlas coordinates change, sources, source state change, and also we don't have any alternative tiles set. So the red one is 0, 0. Let's 0, 0 for now. And here we should have a red cell on the 0, 0 position when we turn it on. As you can see, this one works. What thing I like to do personally is setting some constant or any kind of variable here with something like red, and setting this one to our coordinates so that we know what we're doing here. As you can see, this will work the same. I'll do it for the rest of the tiles. Okay, I've done it for all of them, and it works like this. Now, on the other monitor, I have a dirty helper for handling mouse input, because for life I can remember this one. Okay, let's comment this for now. Here we're basically checking when the mouse left button is pressed, so let's print our event position to show you. Okay, now when I press the left mouse button, it shows its position in the output console here, but still we need a integer coordinates. So to do that, we can use the function called local to map. In the Godot 3 it was called something like world to map, but now by pressing we'll get the integer coordinates that are calculated using our tile size and the local coordinates. So now we can spawn our cell wherever we click by doing this and taking our position and putting it here. So now whenever I click, a red cell should spawn, and as you can see it works perfectly. Now let's say that we want to iterate over our tiles that we spawn. We can do something like, for example, creating an array of our cells here and some kind of iterator that's starting with 0 and boundaries being length of our cells order. What's the problem here? Green is not okay. Green. Okay. And if we have something like this, we can use order of our cells with this one, and here we increment this one by 1, and if this one will be bigger than its maximum value, then just put this to 0. And now we should have iterating different tiles. Okay, I know what the problem here should be greater or equal. Okay, talking about other useful functions, this one here we can press whatever we want. But let's say that we want to force the user to put tiles next to each other. We can do it by checking distance between our tiles. And because coordinates have types of a vector 2 with integer, I think that the distance function is unavailable, but we can do it by using the length function. So let's set our starting position to vector 2 0 0, and also already put something on our starting position. For example, or maybe just leave it as this. And now here only set cell if our target position minus our starting position will only equal to 1. So basically the cells are adjacent to each other. So let's see whether this one works. Okay, I'm trying to press here, it doesn't work. I pressed here and it works. Okay, but we forgot to change our starting position. Starting position here, and here let's change this one. Now we can press it like this, but we can do it here. Now let's modify the starting position a little bit. Let's go back to our tile set, and we have one tile left here. Let's pick this one. Let's pick this one and modulate it, maybe some purple color. I'm checking here, this one have Atlas coordinates 1, 1. Okay. Here, call it purple. Let's move the starting position from here. Let's say that we want to use our editor. Go into the editor. Here, create the use a paint here. Now we can paint. Put a purple tile in the random on the random coordinates. Go back to the code. Here, instead of starting position, create a previous position. Make this one on ready. And now we need to find where our purple tile is, and for doing that, here we'll use something like get used let's check how was it called. Okay, we're interested in this one. I'm not sure what it doesn't show into the pins. And here we're using everywhere we're using clear 0. We also don't use any other sources, and here we need to pass which style we're interested in. So in our case, this one will be purple. Okay, and we also need to change the starting positions into the previous positions. Why is it crying? Okay, because this one returns all of the cells. So if we have only one, then we'll the first one. And now we should be able to put the cells, but only next to our purple. Let's test. We can do this here, but it works here. Okay, there's one more thing that I want to show you. Let's add a simple label here. Let's create a ready function. And here let's change our label text to counter of how many cells we've used. And let's start with a label counter being 0. And here let's update our label with something like how many cells we've used being get used cells on layer 0, and convert this one to string. Okay, let's check how does it look like. We have 0. Okay, but this one show coordinates, so that this, let's put a length here and this one will work. Or maybe not, we still need to. Okay, as you can see, it works. This one will be it for the basic interactions, but